Hello, good morning, good afternoon, good evening. This is Ed Burke with Web 14, Lambda School, etc. with my man Carlo Clamucha, part of my group for Lambda Labs, Labs 9. And today we'll be going over the climbing stairs problem. So, Carlo, how are you today?
I'm pretty good.
So the classic problem that I find we all run into is the climbing stairs problem, in which we attempt to figure out how many different ways we can climb a set number of stairs using one step or two steps. How many variations of, say, five stairs can we climb using one or two steps? And this is a example of the Fibonacci sequence or recursion that will come up in programming, in which we can determine these variations by simply just adding them together plus one. So what I mean is, if we have, say, two steps, n equals 2, the solutions for this would be one step and one step, or two steps. The solution to three steps would be one step, one step, one step, two step, one step, or one step, two step. Now, this is all well and good for two and three steps, but then it gets a little bit more complicated when you get to four steps. So the logic that helps us with this would be to, let me close this terminal, would be to simply take the steps of 2 and 3, that is to say, the steps that come before four steps, and we're just going to add them together, because all these variations would hold true for four steps. The only difference being is that we would add 1 and then 2 to them, respectively. So for three steps, we would say 1, 1, 1 plus 1, 2, 1 plus 1, 1, 2, 1. That is plus 1. And then for two steps to four steps, we would say 1, 1, 2, 2, 2. So herein are all the variations for four steps. Now, if we were to take that, say, to the next step, and to completely beat this horse to death, we would say 1, 1, 1, 1 plus 1, 2, 1, 1 plus 1, 1, 2, 1 plus 1, 1, 1, 2, 1, 2, 2, 1. And the third step, 1, 1, 1, 2, 2, 1, 2, 1, 2, 2. And lastly, the second step, 1, 1, 3, 3, 2. And from the first step, 1, 4. So here are all your variations for 5 steps, and you repeat the process until you get to, say, the 100 step. But Carlo, I'm not going to bore you with that, because I'm sure you get where I'm going with this. You're picking up. So quite simply, in closing, the formula for this is quite simply f of n is f of n minus 1 plus f of n minus 2. Whoops. Minus 2. That is to say, this is the culmination of the step before, and the step before that is equal to the concurrent step, or the step that that you're trying to find that comes after those steps. So
You're trying to make a function that calls itself.
yeah, in a way, this is going to be a recursive function. That is, it feeds itself. It is a snake eating its tail, so to speak. If I had an emoji for that, I would place that here. It's tail, but I do not have an emoji in VS Code. So, in closing, recursion is cool, and so is the how do I spell Fibonacci? Fibonacci sequence? the Fibonacci sequence is cool because the universe is always expanding. Thank
That's a
you,
cool one.
Carlo. And this will end it for my presentation for my whiteboard. Lab 9, January
Yeah,
20th.
that's pretty cool.
Carlo,
That's pretty cool.
Ed, thank you guys. Thank you, Carlo.